What's up, everybody? Welcome to Tesla Fix. Today, we're gonna discuss a topic that's pretty much in my heart right now. We're gonna talk about the Tesla Bot today. And of course, when we talk about the Tesla Bot, there's one person we cannot miss, and that's Scott Walter. So everybody make some noise for Scott Walter here. And yeah, Scott, thank you for being on again. I really enjoy the conversations we had last time. I mean, we had 2 episodes already, one with Dr. Know-it-all with John Gibbs. And yeah, I really enjoyed them and can't wait to hear what you have to share today. Yeah, let's jump right in. And yeah, maybe you can just tell the audience, of course, what you do, what you're up to.
So guten Abend, Jan. Danke für die Einladung. I'm Scott Walter, and I do robotic simulation as my day job. I've been doing that for about 4 decades now. And so I can sort of get an idea of what they're trying to do with Tesla Bot. So Tesla Bot is more than just trying to be a humanoid robot, but a humanoid robot that's kind of work in a factory setting. And that makes sense to me because I could actually see where the application space is going to be. So we're getting little updates here and there to kind of find out what the progress is, to be able to sort of adjust where we think they are. We, of course, are very hopeful on how quickly a Tesla Bot's going to come out because we've heard indications of that. So sometimes we might be getting a little bit ahead of where we hope they are. And so now we get sort of an update so we can maybe calibrate our expectations a little bit better, get an idea of what it's going to do. But in the end, I think, they're making progress. It's moving along, and we'll probably be seeing something within maybe the next 12 to 18 months that sort of confirms everything we've been talking about.
Yeah, awesome. Can't wait to see what movement they're gonna do with the Tesla Bot, because today we have a lot of different topics. Highlighted right now. I mean, the change of X, like Twitter changing to X, is a big one, and in the Muskiverse or Elon-verse, however you ever want to call it, there's happening so much every day. But I think the Tesla Bot is such a fundamentally important topic that this can't be missed. And I think every detail we have is actually pretty important to get to see the approach they're doing, how it's developing, and especially for you as a robotics nerd and a aerospace engineer by heart and also learned, of course, and what you do with the simulations. I think, yeah, that's one of the key topics for you. Or what topic for you is also very important? Is it just the robot or FSD and what are your hard topics of Tesla?
Well, I'm tracking all of it, but I think I have maybe more insight on what's going on with Optimus than I would in some of the others. But I appreciate the value that all those others bring to the Tesla story. And of course, if it's just about the Tesla cars themselves, then Tesla is an automobile company, and not much more than that. And you can't get really super excited about it. But there's all these other business units within Tesla that makes a lot of the hyperboles very, very excited. There'll be some people that are saying that their energy business is going to be what really makes them take off because there's just so much potential there. Even though right now it seems like it's going nowhere, but the battery storage is probably going to be a lot, and eventually it could be solar. So there are going to be people on that side of the equation to say it's good. Now, I think, there's definitely going to be profits there. It's going to go well. I think there's a good business case. The cars I think are exciting, but eventually there'll be other people that are other OEMs that are producing EVs. So what is it that sets them apart? And again, the hyperboles will point to FSD as being it. And pretty much the argument within the hyperbole community is what makes Tesla go to the moon or further? Is it FSD or is it Optimus? That's really where it is. And then like the third player is like, it might be energy, but most people think it's like one of those two. And I'm not going to sit here and say which one it is. I know that, they both have great growth potential, robot taxi versus, robot in the factory kind of thing. And, my feeling is that in some way, the Tesla Bot will be affecting the bottom line sooner than robotaxi.
Wow.
Okay. Now, okay. So let's make sure we kind of get that out there straight. What do we mean by the FSD exists right now, but it's not robotaxi. All right. Sure. So they are making some revenue stream from FSD. That's pretty clear. The question is the amount that's come in, has it paid for itself, given the cost of everything else it had to put in there? So it might be about break even, or they're seeing some cash coming from that. So you can make the arguments like, well, FSD is generating cash flow. There's no doubt about that. But robotaxi doesn't exist yet. We're almost there.
True.
And the question is, are we going to get there before we see the bot doing something? Now, the thing about the bot is that most of the observers, myself included, feel like the Tesla bot is not going to be sold for quite a while. And quite a while, maybe it's not for at least 5 years. And if it goes outside of Tesla, it goes outside in a leasing model, not being sold. So at first, they won't even lease it because they're going to keep it internally. So it's like, well, I mean, how are you going to be making any revenue that way? And that's not what I said. I didn't say anything about revenue. I'm going to say it's going to affect the bottom line. And it comes down to it's going to be saving Tesla money in producing the cars. That's the whole idea. So eventually, the COGS is going to go down because now suddenly one of the larger inputs that you have to have, the cost of labor, is just going to start to go down, 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 down. And then there's like another side of it you got to remember is that part of the reason of putting robots in there, one is to reduce the cost. Yeah. But the other side of it is also quality. So you can make the argument that even if a robot cell costs you a little bit more to operate than if it was a purely manual one, because of the quality that you're getting out of it, that is where you also save because, returns kills you, scrap and everything else. So when you are having consistently produced product, everything is done the same, that also saves you a little bit. So there's a lot of places it's going to save you money. And, when you look at the labor rates and everything else and you start putting Optimus in a lot of places, it will hit it. And so I think it will hit it, start hitting the bottom line, maybe sometime next year, definitely by 2025. You already see it. And why am I saying that? Okay, because I'm hanging my hat on Elon's words. That's why. Is that what he said last week? And maybe before we jump the gun, do we want to go through exactly what the statement was? Because what we're talking about now is one of the few glimpses we've had into Optimus since the shareholder meeting. Yeah. So this is just kind of the 4-minute remarks that Elon made, and that's it. There have been quote, some other leaks, but we're not sure how trustworthy some of those leaks are. People talking about this and that. It's not like the Cybertruck sightings. It's like, oh, people are seeing Cybertrucks every day. We're not seeing Optimus every day. So we really can't tell you where it is. We have to wait for some sort of video or press release or statement from someone within Tesla. And Elon's made that statement.
Maybe I can just jump right in here and discuss the developments of the Tesla bot actually. So you've analyzed it pretty thoroughly at AI Day. You've analyzed every frame of the video and showed how they simplified the robot. And so the simplifications is going on pretty long already, of course. And now you had the thesis of the Tesla bot will have like smaller task, replacing maybe those drone robots. Maybe that are some use cases instead of a human that has to do it. And we in the last episode, the bigger episode we did, the first one we did, you've discussed how they gonna handle those machines that also aid the humans for lifting things, those power lift cranes or how they're called. Yes. And so there are already so many use cases in the factory already that we could see Tesla bot doing. And it's interesting. And then we had the showrooms actually were delivered those Tesla bots left and right. So we had many Tesla bots going out. That this implies that they have like more iterations of the Tesla bot already, maybe 10. We don't know how many, but So it's interesting to see. Do you have any? Did I miss something? Is there anything else we had?
For the most part, the thesis is that the bot does not have to do everything a human can do right away. It just has to be able to do something useful. And in that case, we're just looking at the low-hanging fruit, as we've always called it. And we've been able to identify many tasks in the factory which are low-hanging fruit. So like a full-on assembly task requires a certain amount of dexterity. So you would need a bot that's a bit more. But a loading and unloading task is really, really simple. So there's a lot of examples like that. And we've seen examples of the human operators doing that. It's usually what we call, the human is feeding a robotic cell somehow just by picking up some parts that are very easy to pick up and very easy to put down. And when they get too heavy, they have a lift assist that allows you to do that, which is how the human gets their superhuman strength to be able to pick up a really heavy part and bring it over. And that's something that the bot would be able to manipulate and be able to do it nonstop. It's a very simple task. It's repetitive. It's tedious. The bot could do it. And, that particular operation, if you're running it almost 24/7, for, that one operator could be close to $200,000 a year to just keep on feeding that cell. So you could say, wow, that's a lot of money I can save in just that one operation. What if I go for like a couple other operations there? Then you start actually making real money. And so that's the whole thesis, is that it starts out very simple. It does not have to have the dexterity of a brain surgeon right away. Eventually it gets there. But the thing is that you can learn so much by starting out at that and then saving the money that it justifies itself. And you get that flywheel effect. It's like, the margins are going up. Why are the margins going up? It's like, well, because we found a cheaper way to manufacture. And eventually it'll make it into the other areas. And of course, right now we want to know is like, how many bots are out there? So we know there have been some iterations. We know there have been some on display worldwide, but we're not sure exactly how many are out there. And those are not full-fledged Tesla bots. They are kind of, the prototypes of putting everything together, probably the innards of the motors, there's nothing in there. You don't see any wires. So it's more or less a mannequin. But they've been on display. And we know there's probably more than one on display because there seems to be one always in the Peterson in LA. There's one that seems to be roaming around in Asia that, was in Shanghai, and then I think in Seoul. I think it's the same one. They probably just transported them around.
Okay. Interesting. I thought there were two, maybe.
Yeah, maybe there's two. That's what's really hard to tell, is that maybe they have one there. And then there's one floating around in London, because there's one spotted, I think, 2 weekends ago at an affair over there. And then there's one in the showroom in New York City. And then there was the announcement that, we're going to start bringing them into the showrooms. And there's a lot of Tesla showrooms. And whether the plan is to do all of them, or is it just going to be this rotating exhibit to eventually bring people in. So that's Tesla marketing right there. Because if you say, hey, the Tesla bot's going to be here, people are going to flock to that showroom. We don't know how many there are, but I was at a Tesla event this past weekend, and there was someone from Tesla there. And I was like giving him the third degree to kind of find out. And the impression I got is that, they're planning on having more of these things out there in a lot of them. So it's not like it's just going to be one in New York and then it's just going to go on a road trip or something like that. The impression is that they're going to have it, but it's going to be mainly at like the delivery centers, because that's where you get most of the traffic. That's where everyone wants to see it. It's probably not going to be in the shopping malls. Okay. So what does that mean? Well, as they're doing the R&D development, they are trying to figure out what it's going to look like and first get an idea, some sort of pathfinder. It's like, we put all these bits together. Do they go together? How are they going to go together? And they might notice there's a problem. They come up with another iteration. And at some point they've got a version. It's like, well, there's nothing we can do with it. It's just scrap. But, maybe we can put it on display. So why not? Yeah. And they probably have some others and others and others. And I would like that if people start noticing them in showrooms, first to start putting them on a map, find out where they are, when they were there, and then you just got to count how many of these display units they're producing. Because I don't think they're just creating display units for fun. I think a lot of it is that it's probably part of not just the design process, but could eventually be part of the ramp-up process, where you start seeing what the production is like and putting these things together. And when you put it together, you have a choice of either disassembling it, but you might say, well, we don't really want to do that, because disassembling it, we might break a few things and not really get an idea of what it's like to put it back together. So, I might say, once we produce one of these things, and it may not have everything live in it, but some things are like, what do you do with it? And then if you start seeing a lot of those, now you can start saying that, wow, they must be going through a ramp-up phase. But we know they're not at a ramp-up phase right now. Why? No, because Elon said that they won't really be going into it. And again, that kind of comes from the statement. I don't know, have I been sharing the statement or not? If it's up on the screen?
It's now on the screen.
Okay, it's on the screen. So, my voice is a little bit hoarse today, but this is the transcript of what said. So this is one of the questions that shareholders were able to vote on that fortunately made it in there. And I'd say Elon spent maybe more time answering this question personally than some others. There may be another one or two in there that he did, but there were others he deferred to have his management team answer. And this one he took on himself, and he spent about 4 minutes on it. So the question is, how many Optimus bots have been made, and when will they be able to start performing useful tasks? So, and this was kind of funny, is Elon didn't give us a straight answer on how many there are. It's like,
Yeah.
I think we're around 5 or 6 bots. We're at 10. Okay, so
I guess.
so it was like,
Yeah.
first it was like, I was crestfallen. I was like, what, single digits? And then like, at least get to the 10. I guess, and the reason why he's saying is, I guess depends upon how many are working and what phase. That's understandable. Maybe they have enough parts for a dozen or so, but they're always in a state of disassembly or being tested or something like that. So maybe if you were to go down there and say, I want to see a demo of the Tesla bots, and it's like they can only get maybe 5 or 6 walking around at a time. The others are just overdoing whatever. So that's kind of where they are right now. I was hoping they'd have maybe 1 or 2 dozen, but it might make sense because when they, and then he says, but there's more every month, so that we know they're making at least 1 more every month. So, and next month we can say there's 11. In September we'd say there's 12. All right. And then he mentioned something that we've heard before, but you'd have to be paying really close attention to this stuff. But we've known about this. There's a lot of interesting things about the Optimus Bot. We found there are actually no suppliers that can produce the actuators. There are no off-the-shelf actuators that work well for humanoid robots at any price. And then as Elon said it, suddenly you heard someone say something in the background. I didn't know who it was at first, which is why I looked for the transcript. Certainly not compelling. So the point is that you cannot produce an off-the-shelf, a robot with off-the-shelf actuators that would be compelling. The actuators just don't fit the bill the way they are. And they seriously looked at this problem. And so this is Lars's way of saying that Optimus is actually compelling. It's the logic looks a little bit backwards here, but it's like, it's a double negative in there sort of somehow that he thinks Optimus is a compelling bot because they're designing it with the Tesla designed actuators. And remember, he is the internal user. Lars, he is vehicle engineering. He has nothing to do with robotics. So vehicle engineering is also going to include sort of the aspects of the manufacturing, because that's just how Tesla works. You just don't have, you design a car and then let these guys over here figure out how to build it. It's like, no, how you build it is part of the vehicle engineering, and then looking at those processes. So Lars is convinced that this bot is going to do the job for him. So he's definitely happy. Otherwise, he wouldn't have made a statement like that, which is why I wanted to pin down who said that. And then, yes, there are no humanoid robots that can do things that humans can do. So we're actually had to design our own actuators that integrate the motor or the power electronics, the controller, the sensors. So what he's pretty much talking about is like, yeah, you can go out and buy a motor and you can buy like a control board, you can buy some sensors and stuff like that, but that's just not how it has to be. It all has to be integrated in, and it has to have the right power package that you need as far as like the torque curves and everything else. They want to make sure you're not consuming too much energy or anything else along the way. So they have to make sure they optimize everything. And there was a famous screen sort of showing that I can sort of bring up. I'll just sort of finish this maybe I'll try to bring that one up. You might remember there was a slide back in AI Day 2 that showed the 6 different actuators that they have. Yeah. And the curves that were there. And somewhere in here. Yeah.
So far the statement already is pretty interesting, and your interpretation of what he said makes sense how you described it. I also think that he says that actually, the Tesla bot is pretty compelling, but not the actuators that are from third parties. And
yes. So
pretty interesting.
You have to get that from there. So and I'll just kind of zoom in a little bit here. I've got this in the power. So this is a PowerPoint I put together to figure out how much the Tesla bot's going to weigh, to verify that it meets what they say it's going to weigh about 120 pounds. And I wanted to verify and validate. Actually, what I wanted to do was find out how strong it was, because remember in the Investor Day video, they showed the Tesla bot carrying an arm over to the other bot. And at one point, it actually kind of put its arm straight out, holding the other arm. I'm like, oh, how much is that payload? How strong is it? What's it able to do? And so I was really more curious, like, how much does the limb weigh? And get an idea of that. And the only way to get an idea of that is to look at the servos that make it up and count up the mass from that. And fortunately, right here, these are the 6 custom actuators that Tesla has come up with. And they gave the weight right there. So by having that weight, it was a lot easier for me to be able to figure that out. Now, what they did is they did a series of simulations of all sorts of different tasks that a human or the bot would have to do, squatting, lifting, walking, whatever they were. And from it, they get an idea of how much torque was sort of required a particular joint to do that. And based on all those things, they get sort of an idea of the performance requirements, and they try to optimize it. And by doing that, they realize that certain joints have such a similar torque profile, they can be the same motors. The idea is because they have a total of 40 actuators that build it, but they don't have 40 different SKUs. The idea is to try to reduce that number. So up here in the shoulder, you have 3 actuators up here, but they're all the green actuator. They're all the same actuator. And then you see those same ones show up down here as well. So you've got 3, 3, 3. So 9 of that 40 is right there. Now, there's also the structural actuators, and then there's ones in the hands. So with the hands, you've got 12 there. So that's really 28 structural actuators. Then you go through here and you'll see some others like, you can't tell here, but there's a servo here and there's one right behind it. So there's actually 2 purples in each legs because you've got the hamstring and the quad, right? one for the knee, one for so those are both there. So that you need actually 4 of these in total. And you see some of this, more brighter green here for along the wrist, and that one is kind of unique. It's like, darn it, we had to come up with an actuator just for that, just to take the hand to do that. Okay, well, that's what you have to do. And the yellow, but they sort of found that we were required to put some of these in. In some cases, we could use them multiple times. Like right here, the elbow is red, and then down here at the ankle, you have 2 here. So they had to find the mix, and you'll notice it's a mix when I go back of rotary and linear drives, because they found in some cases you were trying to take a rotation and convert it into a linear motion anyway. And there's a bot from Fourier in China that Herbert and I took a look at a few weeks ago. That has some similarities to Tesla bot, but all the actuators are rotary. And when they get down to the hamstring, they have like a motor that's about that big. It's huge.
Wow. Okay.
And then all they're doing is they have a connecting rod on it. So the reason for having a rotary robot is if or a motor is that if it's right at the joint, it makes sense. But in many cases, you're not putting at the elbow a joint. The elbow is an idler, and the motor might be back here. And so what they do sometimes is they take a rotary motor and they stick a linkage mechanism on it to make it move. It's like, well, wait a minute. If you're taking a rotation, try to make it linear. Why don't you just go linear all the way? And so that's what Tesla has decided to do, is in those places. So the Tesla leg is more compact than the others, because if you look at that other one, it's quite the package they're going to put there, because they realize, like everyone else, your hamstring needs a lot of power. Your quadriceps need a lot of power to be able to walk and do what you want. So they're putting it in a more compact package. And again, so one of the things that Elon sort of stressed is that he used the term lighter and tighter. So if I kind of finish his quote, which is out here somewhere, that part of the design was not just that they were lighter and tighter, but they could actually be manufactured. So again, the Tesla philosophy: make sure we can actually build these things and make them function. So here is
his lengthy reply.
Right. So okay. So then we talk about right here. And then, of course, we'll be using the same inference hardware as the car, meaning that, the brain of the bot. But we were designing these actuators, designing them for volume production. That's very important. And it's not just Elon saying that. That's been said by many people within the team, going all the way back to AI Day 2, of how we set it up for volume, what we have to do. We don't make it out of titanium because it's going to be too costly. We want to make sure it's easy to produce everything. So they're not just lighter and tighter and more capable than any other actuators wherever they exist in the world, but it's also actually manufacturable. So we'll be able to make them in volume. Okay, so that's very important. Now, this next statement here might be kind of key why we aren't already seeing 100 bots or 200 bots out there, and why it's kind of a small number. The first Optimus that will have all of the Tesla-designed actuators, sort of production candidate actuators, integrated and walking around, should be around November-ish. So when I first heard that, I was like, the first bot to have the Tesla-designed actuators, what do we see walking around? I thought those were the Tesla-designed actuators. they are the Tesla design actuators, but you'd say they're the version 0.9. They're the ones that it's built by a craftsman. It's not built on the production line. It's being built in the lab.
Yeah.
And remember, we need 40 of these for one bot. Yeah. And they're, trying to churn those things out is probably not that easy. And so they've got just the number of bots they probably think they need right now with the number of team members to make sure they're busy playing with a bot all day. Because obviously, if you've got 100 bots and you don't have like people to play with them, it's like, what's the point of having 100 bots? So they have enough. I thought they might have a little bit more for the AI, just to get more and more training. But it may actually not make sense to have that large number right now if all the actuators are handcrafted. Because every time you build one of these actuators handcrafted, it probably has slightly different performance characteristics than the other. They're not identical.
Yeah.
And so what that means is that, no two bots are actually that identical. They're close, but there might be enough variance that it just becomes really hard to train them. And you want them to be the same, because one of the key things that we want to do is that once we teach a task to one bot, all the others can do it. But if the bots are really different, they have a very different kind of signature
that's
capabilities, then suddenly it might be, wow, they don't work right. Now, you have to be able to deal with the fact that over time, the actuators are going to just change their characteristics in the bot, just from usage, just from temperature, just from everything else. But you want to probably keep it within kind of a narrow window that is manageable. And so they might be like, let's not really go crazy with the number of bots until we're able to spool up the production line for the actuators, which sounds like it's November-ish. So around then, they're going to start having it. And that's my prediction. November-ish is when we are going to have AI Day 3.
Yeah. Makes a lot of sense.
Yeah,
and
they're not going to. Go ahead.
Please go. No.
Because they pushed the last one off, because the AI Day 2 was supposed to be end of August last year. And then it kind of got pushed off to the end of September. Why? Because they wanted to have something to show. So it's going to be the same thing. They're not going to say anything about, they didn't commit when it is. And once they see, if for some reason they get things going end of September, then we'll see it in October, but November-ish, something like that. The other key thing it said is that, and then we'll start ramping up after that. And hopefully that means after that means like the next week, it's like, then, we'll wait a quarter or two, it's like, they're going to ramp up. So, any thoughts or concerns so far?
I wanted to add something here, because I think it's very interesting to see that that's the whole approach of Tesla, that they target mass production, of course. And also in this case, it makes so much sense, because you need standardized, like you said, you need really standardized bots to play with, to have a similar bots. And it's interesting it's just like when I'm from media design, that's why the printing analogy makes a lot of sense. So if you want to print something offset, it's for like a bigger quantity too, then it makes sense. Everything else going to be printed just normally with a normal printer, more or less. And I think that's the same case, because to produce 4 robots or actuators for 4 robots, standardized actuators for 4 robots, you already have like a line or a test line that could be expanded very fast then afterwards. But at first you have to have this, and it makes sense, because then you have the same actuator. Then when you come onto problems with 4 of those Tesla bots, maybe you test around and you realize, the design isn't good for mass production, we have to change the line again. And then they come to the part where it's really interesting, because they build the machine that builds the machine, actually. So the robot, you can design a robot by hand and plug it together and do it by hand, everything, and have somebody to CNC machine part and do everything, every design by hand. But then the iterations are like go into the hundreds maybe, and this doesn't make sense because they want to have a viable line as fast as possible. So that's just what I wanted to add here. And that's sort of the importance, is that they have a lot of tooling and everything there to make sure that they can put the windings into they need and whatever they're building and the CNC machines. It's a slow process, but there could still be enough variation in there that they can't quite get it where they want to have. Now, of course, the bot does have to be able to deal with it, because, FSD
works on many different cars, and all the cars are a little bit different. And even your own car is going to vary over time because, if you hit a pothole or something and suddenly you're out of alignment, FSD will still work. It wants to go straight and it realizes, it pulls a little bit to the right. So it just kind of steered a little bit to the left. It's kind of annoying, but the whole idea is it knows where it wants to go and will compensate. If it's really off, of course, you would have a problem. So, the AI is going to have to learn to make those adjustments because that's just going to happen anyways. But still, it's kind of nice to be able to start at someplace that's really close. And again, with the training that's going on, there's two ways you could train the bot. Is that you could build a piece of hardware, put some AI in there, and just say, start learning and have it figured out. And of course, you've seen that they're already doing that in these virtual spaces where they will make these virtual little bots that figure out how to walk on their own and everything else in this virtual world. Yeah. But it takes millions and millions and millions of iterations to do that. And you don't have that luxury with the bot. You don't have that much time, and you don't have enough of them up there to be able to do that then you start putting it on in. So you want to make sure that when you turn on the bot, it already has some innate capability, which has come from the pre-training that we've done in simulation. And the simulation can get you pretty close. The question is, does it get you 80% of the way there? Or does it get you 90% of the way there? It depends upon how good you're able to model the physics in your simulator. And they're probably able to model it pretty well, but there's a trade-off is that the greater fidelity you get in that physics model, the fewer iterations you can do over a certain time period. So you have to decide, okay, where do we kind of cut the corners to be able to get this thing to evolve really quickly to where we like it, and then maybe start turning on. But at the end of the day, it's going to have to learn real world physics. And you have to turn it on and do that. But you should be pretty close. So you probably don't need to have that huge number right away. And then when you finally get a fleet, which is consistent, then you can start to do it, and you'll do the ramp up and then what comes out. And then I think the next point that Elon makes after this, which is, after the ramp up. So the first thing is like, oh, good, they're going to start producing robots. Does that mean we're going to have a couple of dozen by the end of the year? Are we going to have 100? Are we going to hit, what was my guess of 500 or 1,000 like Randy Kirk thinks it's going to be? It's still, I'm still hopeful that I might be able to meet my number. Yeah. I'm not quite so sure about Randy, but if we can get or triple digits by then, I'll be happy. If it's north of 100, I'll be pretty happy. Which is feasible.
I'm going to bet on you, of course. In that sense, I trust you.
It's feasible, and of course they could have 100 right now as well. Yeah. But just because they could, the question is, should you? And right now in their schedule, they've realized that we don't need 100 bots right now because it doesn't make sense. We're going to wait. And even then they might bring up the line a little bit and only make a dozen or two, check them out and do a little bit more. Now, their ramp up will go a lot quicker than a normal factory, because it's a much simpler product. The most complicated things, of course, are the actuators. Yep. The second most complicated thing is the inference chip that's going in there, the FSD computer chip. But they've already got that under control. Otherwise, wouldn't you see the FSD out? So that's like something you don't have to worry about. So the main thing is that getting that spooled up. The rest of the stuff is pretty standard. You'll be able to, not that it won't have its little snags here and there. They all do, but they should be able to work that out pretty quickly. We know they're hiring people to be manufacturing engineers to get this thing up. So they should spool up really pretty quick. And it's just a question of how rapidly they want to do that. If they really wanted to make sure they had 10,000 bots out by the end of the year, they could probably do that. But I just don't think they see the need for that. So it will be a smaller number. Yeah. And so they'll get enough. And then the question is, the second part of the question was when we'll start to do useful things. So we'll start ramping up and then it'll be able to, in terms of when we'll be able to do useful things, we'll first be trying this out in our own factories and just proving it out its utility. They're already doing that. That's already going on up in Fremont. We've heard enough rumors about that, and I'm pretty sure they would have already been doing something like that. But I think we'll be able to have it do something useful in our factories sometime next year. I'm pretty confident of that. I'm pretty confident too. And I think Elon gave himself enough wiggle room. He didn't say early next year, sometime next year. So he's got the whole 12 months. And I think it's going to be sometime in there because I'm pretty sure they're out testing it during off shifts and everything like that. So they're not impacting production, verifying that they're happy with the design. Things are looking pretty good, find out what the tasks are going to be like, and then they'll be up and going. So that's sort of the state of Optimus in the factory. Now, there is like this last paragraph. I don't know if we want to tackle this one here, which was almost a non sequitur regarding the Optimus and being paired with Neuralink. And the idea of prosthetics, which is a completely different, it's almost a canard for me. It's like, well, it's a little bit out of my domain. I could understand, that potentially, being an application.
We can tackle this maybe for the end of the episode. I think it's a great example of the future of Tesla Bot or what this technology could bring. So we're going to tackle this a little bit further out in the episode. But yeah, I think that's pretty interesting what he said, especially with sometimes next year that the Tesla Bot will do something useful. And I think, this is such a new frontier of robotics that we are witnessing right now, because no company so far, in my opinion, but I'm not in the field, so you might correct me, and I hope you do, is that nobody, that's unprecedented that somebody wants to scale humanoid robots to mass production and go from this approach, because it's such an expensive approach. I think nobody, producing like 10 of those robots by hand might be possible, but thinking about tens of thousands of robots, and that's a whole different game and different ballpark. I think that changes everything. Every decision they make, they have to make it so simple, the robot, that it's producible actually. And then the interesting stuff is, if Tesla manages to implement those Tesla bots early, think about it. In the next course of the next 5 years, when Tesla Bot is actually in the factory and doing some useful tasks, let's put 10 years on top of that. They are the first in the world, the first company in the world that utilizes humanoid robots in their production. And then that means that they're going to iterate much, much faster, because they're going to iron out those nooks and crannies and way earlier. And this is so interesting. And yeah, this is really much so important also for the future of humanoid robots. I think, that it's a necessary step, and it's absolutely science fiction for me to witness this, because of course I'm not an engineer, I'm not in the field, but for me, witnessing it from the sideline more or less is so interesting to see that. And I think people don't really realize how big this actually is. People cannot grasp it actually, and I think with all those mass companies, we're going to see that in maybe 15 years, people will realize what's happening actually, or what was happening in the beginning. So, but please, I want to interrupt.
There's a lot of times when you have an emerging technology like that, it's best that it be developed by the end user, because they know what it is that they want, so they can iterate really, really quickly. And when you start getting a product that's more defined, then you have too many users and all the requests are going there, and you have to wait. And then it's like 3 months, 6 months before it comes. And when it comes, you're disappointed because it's not quite what it is. And you've got to give them the feedback. That kind of slows it down. And the early CAD systems did not come from these computer companies that were creating CAD. They were actually coming out of the aerospace companies that had a need, and they developed it internally. And eventually they spun those divisions off and everything else and get their end users. And then you'll hear everyone complain today how long it takes for a new feature to get added into one of the major CAD systems. Now, you might say, well, it's really unprecedented for an automobile company to start producing, their own robots for manufacturing. No one's ever done that before. It's like, wrong.
Okay.
Volkswagen. Ever heard of the Volkswagen robot? Okay. Kamau basically was part of the Fiat group, came out of there. You have Acma robots, which was part of Renault. You had GM had a joint venture with Fanuc, with GMF, and they were developing their own paint robots. As a matter of fact, the Fanuc paint robot came out of GM research. So they're all there because they're trying to solve these manufacturing problems. And they were looking around saying, there are no suppliers, there are no vendors who are doing this, so we're going to do it ourselves. And so you get the benefit from that. And eventually, when it gets mature enough, maybe it goes out there, maybe you spin it off, and now you can start talking about, we have this larger collective. But it's really something else if you are your own user. You understand that, and things will go over. So I do see that things will go very, very quickly. And it's a different robot. The robot company, the automotive companies have done this for years. And even before they did robots, they were working on other kinds of ways to automate.
Yeah.
And then eventually they found there these other sub-suppliers, or again, they spun it off because they said, okay, this is not part of our core. We need to spin it off. So, I mean, I know there are arguments that eventually the Tesla bot might be a division that's spun off from it. And yeah, maybe, but I don't think it's going to be immediate. I think it will, maybe it's 10 years from now or something like that. But I don't see something immediate because they want to maintain that internally. And they're going to keep on finding more and more use cases along the way. So we see that coming up. We see it doing useful. And now we have to decide, what is useful? How would you define useful?
Yeah, useful would be replacing a simple task. It could be just picking something up and bringing something over to another part of the factory, but doing that 24/7. Making a line where, or making a process where the Tesla bots are being replaced by each other, and just with maybe just one task, one robot, one thing they're going to do.
Let's look at it this way. So Jan, I invite you over to a dinner party or something like that, and I'm in the kitchen, we're making subs, and I say, Jan, make yourself useful. And you come up and, you just help me and say, oh, what do you want me to do? Oh, okay, just go ahead and, slice the mushrooms or this and that, or help me clean the dishes or do something like that. Yeah. But if you're really inept at it, if you're really, really slow, I'll just say, just get out of here. You're slowing me down. You're getting in my way. You're not being useful. So I would think that's the same thing, is that Optimus has to be useful on the floor, which means it's replacing an operator that's already doing a particular task. And it's doing it well enough that that operator doesn't have to keep coming in and helping Optimus out. It's really is doing it. So Optimus is earning its paycheck at that point.
Yeah.
So right now, I think it's doing a lot of those things. It's just not being useful enough because it's probably not fast enough, or it needs a lot of extra help and everything else. It's sort of in that training apprenticeship role. So once it stops being an apprentice and actually starts producing something, it's useful. Useful to me means it's actually affecting the bottom line. It's not costing more. So you coming in and not knowing what you're doing in my kitchen is not being useful. But if you're able to come in and actually help me prepare the meal, you've been useful. And that's what I see. So I would go by that definition. So sometime by the end of, sometime next year. And it's nice that, sometime next year, he didn't say by the end of next year. So I think he's a bit more hopeful that it won't be at the end of this year, but we can look at that anyway.
Yeah, I think it makes sense what you said. I mean, that's true. Absolutely. And it's so interesting to see that the Tesla, like the Tesla bot has to be paid for itself by replacing a worker somewhere at a task that is maybe repetitive, that costs money. So I think it's so interesting that Tesla already has, because the Musk companies are like, Elon Musk really looks at profitability and looks at the costs as well. And he doesn't want to burn money because they are way out of the startup phase. They can't burn money anymore or live from investments or something like this. Like many startups that are in the field actually do. They are like, they just research funds are poured into those companies, and that's why they don't have to be profitable at this point. And
until whoever is writing the checks decides that
to stop that.
Stop it. And I mean, that's sort of what Boston Dynamics went through, because when Google bought them, there was a mismatch there as far as Google was expecting they would be able to spin off a product right away, and they were still like more in that R&D, and that's why eventually they get kind of sold off to Hyundai. And again, an example that they've been very open about the fact that they've built the bot to prove that they could do it, but they never thought about the manufacturability of it. And now they're having to go back and redesign it to make sure they can do it. That's something Tesla did right away. And again, I don't think they have that many customers for Atlas. They have a lot for the other bots that they're working on. So, they definitely have something there, but there still is not quite clear what the use case is for Atlas and what improvements you would have to add to Atlas. One of the things that's sort of missing is like real proper hands. So if it's going to be used in some factory situations, they will need some sort of either some sort of special end of arm tooling or basically hands to be able to manipulate it. They get some very simple grippers, but they want to have something maybe with a little bit more dexterity. And a lot of the other humanoid robots that are out there, they are looking for niche markets. And I think a few of them were sort of designed to be manufactured fairly easily. but I still think that they may be pretty expensive. They may be 100,000 or more. It's hard to tell the pricing because you've got to like go into contact info and say yes, I'm interested in get actually talk to a salesman. It's like not right on the website on how much it is. So I've always learned that if you have to ask, you can't afford. So that must mean it's a pretty high number there, and probably all of them are going to be around there. The Tesla bot, when they start producing it, the cost will be pretty low. But we think, the initial ones coming off the line, depending upon how the accountants want to work it out, might be pretty expensive. So, number one, number two, of course, will be kind of high because you have all these other costs. But if you actually look at the COGS going in there, it's probably not going to be that much. And so when it becomes useful is when, however, you kind of look at the cost of that bot and then replacing some labor over a certain period of time, when's the return on investment? And I think that return on investment can be pretty quick because, like I mentioned, one of those operations is about $200,000. That's an easy operation, not a high skill, but a low skilled one would be about something like that. And right now, one of those operations can be manned by one person. So there might be two operations that are kind of going on, but they're slow enough that one person can go ahead and do it. Optimus might not be quick enough right now. It can only do one of those within the 40-second cycle time that they have. So you get a second Optimus to go over and do the other because they're not really linked to one another. It's just the two operations that have to be done within that 40 seconds that we think one person can do because we want to get as much utilization out of that person. But if Optimus is not 80% utilized, or let's say it is 80% utilized, but it's just very slow compared to a human, it doesn't matter because we're not paying Optimus $25 an hour.
That's true.
It's like it's just up there and it's just going ahead and running. And so it would be able to be useful and cost effective very early. And then eventually it'll get fast enough that it can do both of those. And then maybe it's fast enough that now it can somehow do three, whereas before you could not even think of doing that with a human operator. And so now it becomes more efficient. So it can be less efficient than a human. All it has to be is more economical. That's it.
Yeah, this makes sense. Yeah, of course. I mean, that's true. I think the analogy with they don't pay Tesla for $25 hour makes total sense.
Yeah.
I mean,
now maybe it costs $100,000 to produce, but if you're somehow saving $200,000, it's already. And then we've got some other guys with blue collars or white collars running around, managing it or something like that. But maybe it's managing a fleet of it. So there is some hourly cost for Optimus, but it will probably be substantially less. Yeah,
and this makes sense. And Elon always tries to put it in there that these things also in the development phase are actually cost effective, or they don't cost as much to the company. It makes sense. So the first customer of Tesla Bot is actually Tesla, of course, in that sense, with saving money at first. And that's why I'm right up your alley with that thesis that they won't sell this thing for the next couple of tens of years, either maybe 10 years or 7 years or 6 years. I don't see them renting them out, maybe just as a test phase or something like this, but not substantially like selling those things.
I think to their suppliers. I mean, the first ones outside of Tesla will be their sub-suppliers. Yeah, that would make sense. So they would go in there and they would get more data from the sub-suppliers, and they would be, by leasing it, they get all the data they need, and then eventually they'll decide it's ready to go. Now, the problem with FSD is that it needs human supervision, because it has to be absolutely perfect before it can really be released. It's just, otherwise there's too many issues. The Tesla bot does not have to be perfect because it's a very constrained environment. It's a very controlled environment. So if we need to put a cage around it, we can still put a cage around it and it'll be okay. And, so long as it looks like it can run 8 hours just nonstop doing that thing and no one actually has to be there, that's fine. It's already useful at that point, even if it can't do a lot of other things. And even if there's some things that might be a little bit unsafe about it, but it's just not walking around. We're keeping it in a geofenced area, and that's it. So that's very different. And that's why I think you can start seeing the Tesla bot being implemented earlier. And I go back to one of my favorite expressions is, a penny saved is a penny earned. So Tesla bot does not have to earn money. It only has to save money.
Yeah. Absolutely. Yeah. Oh, crazy. It's so crazy. It's so science fiction for me still to I mean, when I saw the 2 rockets of SpaceX land at the same time at 2015, that was the point where I thought, okay, this. I know it was interesting before that. I also found it very interesting what they did, but seeing that really it turned a thing inside of me, like it really turned my view on the future as well. And now I think Tesla Bot as well is for me a point where you really see this is so fundamentally different. And also I count FSD into that as well, because they are similar. They need to solve real life vision AI, which is absolutely astonishing. And this is also something that I think is so overlooked. It's not just a car company. People just view it as just, oh, Tesla is the car company, and Elon Musk is this crazy guy who bought Twitter and stuff like this. And it's so interesting to see that, how fundamentally important this also is for the future. It's such a technological advancement like we've never seen before, actually. I mean, this is solving vision. That means they solve the brain and the eyes in the 3D space, and this is who does something like this on this scale, this scale and this pace? Actually, it's
and who
crazy.
Keeps taking these things on? Yeah, exactly.
Yeah.
And landing rockets itself, you think would be more than enough. And then when you build the bots, and, I felt the same way. Is that when I heard that SpaceX was thinking of landing, I mean, it was already amazing that a private company was putting satellites in space, because I'd seen so many startups that were trying to do it and they never got that far. And so it was getting to the point that you're really jaded, and like, I hear this company, SpaceX, coming along, like, been there, seen that. That's not going to happen again. They're going to run out of money before they do anything. That's always happened. And then I think they were doing the landing, and then to see the grasshopper, and I could not believe it when I was watching how the grasshopper was going around. I look at it, like, well, I have an aerospace degree, and looked at how rockets were designed and everything else, and it was pretty much stated like, no, you'd never be able to land these things. They just have to be disposable. The economics is not there. It's just really too complicated and too difficult. And if you're going to do a recovery, with a parachute, or just these other ways. And you did see some of these grand schemes of people thinking about doing it, but it was always one of those, someday, that'll happen.
Yeah.
And then suddenly when I saw that, it's like, wow, someday came.
Yeah,
it actually came. They actually landed a robot, the first stage, and now it's like 200 and something that they've done.
Yeah,
that is just unbelievable that you can do something like that. And then to realize with the bot, it all comes down to the AI, and the AI is there. And something else I should point out, that Elon just keeps on giving these breadcrumbs where you kind of read it and do a double take. So he did a reply to a tweet. I don't know if it was called a tweet because it's before it got changed over to X, so we can call it a tweet. I don't know what they're called now, but
we got to still keep calling them tweets.
Yeah, he had a conversation with ChatGPT, and then Elon said, try it with Tesla AI. And John Gibbs also, he replied to it, and I had the same feeling. Tesla AI, does that mean Tesla has a large language model? I thought that's what XAI was about. Did he type in the wrong thing, or is it like something else going on there? So I have a feeling that Tesla already has their own language model. They've already been able to do it, because I think everyone and his mom can almost create a large language model. All you need is access to a big supercomputer. You just need that. Okay. How to do it, there's plenty of researchers out there that know how to make a large language model. You just need to get the data in there. You just need to be able to access. So Tesla has access to it. They've got some bright minds, so it makes sense to have it. Now, is it exactly the same as ChatGPT? I don't know, but it's probably good enough for what they need for Optimus, because it makes sense. You're going to need an interface. You don't need it necessarily for FSD, though it would be interesting to actually see that go into the Tesla at some point, because there is a voice mode in Tesla, but it's okay, but it's slow.
Yeah.
And it would be really nice to be able to just kind of have a conversation with it as you're driving along. So that you might actually have it in the car, but I think it's really meant more for Optimus. But hey, if we can put it in Optimus, we can also put it in the vehicles themselves. So it would sort of make sense to have something like that there. And there's some possibilities that depending upon how they're approaching the breaking down tasks, that they're using a type of large language model by tokenizing the movements of the bot anyway. So it may be that they needed some kind of architecture like that.
Can you explain this further? Because I don't understand what you mean, actually.
Okay, so
for dummies,
large language models work really well because you can quantize everything. You can discretize language into letters and words, and from that build up the grammars and figure everything out. So that's what they mean by a token. And then they did this thing called I think it's the grammar of lanes. They came up with it. They showed at one of the AI, I think AI Day 2, where they're trying to figure out lane selection and what's going on there, because it was a really complicated problem. And they said, "Oh, this is very much like a large language model." And they went in and it's like, "Oh, okay, we're just going to tokenize all these different lanes and figure out what the grammar is and how you connect one lane to another." So they saw that's a way of handling a problem that was like a novel approach, because we always think of it having to do with language, but you can come up with other kinds of things. And I'm speculating and could be completely wrong, but part of my speculation is that you may be able to start taking movements of your bot and thinking of tokenizing them in a way. So like hand gestures. So we have an infinite number of combinations that what our hands can go through. But if you just say there's certain combinations of our fingers that make sense and others that don't, or ones that are very common. So, we have a very big vocabulary in our languages, but a very small amount that we use on a daily basis. So those are the ones that you would say are very important words to learn, to know what they are. And it'll just be a question of the bot kind of being able to understand what are some of the key sort of gestures you would have with your hand for accomplishing certain tasks. So different grasping tasks. So when you say grab something, that's very universal. It could mean anything. But if I say to grab a pen, then you have to hold it a particular way. If I say to grab a bottle, it's going to be done something else. If I say grab a piece of paper, again, the grasping of that is very different in how you would pick it up. So you can imagine when you're talking to the bot that if you just say grab that, it's going to have to figure out what that is. Or if you say grab the piece of paper, it's immediately going to know, oh, I need to, this is what I need to do with my hand versus something else versus something else versus something else. And so eventually it will be able to build up kind of sentences, let's say the analog of a sentence to figure out what grammatically makes sense for doing a particular task.
Okay.
So it's an analog of that. So there's going to be this internalized language in the bot of what something is. And then there's going to be a translator that goes from the bot language out to English or German, whatever language it is, and back and forth. And that's what large language models are really developed to do at the beginning, was to be able to do really good translations between different languages.
Yeah.
And so
also
now you
translating it to inputs, actually, to how strong something has to be squeezed, or how big the object might be before it even knows what it's doing. Like, it's like, oh, okay, that's anticipation more or less, and something like that.
And that's what we do, and that's what FSD is doing, and that's what we do, is we are constantly running a simulation in our head. When we are driving down the road, we are looking at the road, and we know what we expect the next 2 or 3 seconds to look like.
Yeah.
And if those next 2 or 3 seconds don't look like the way we expect, then we know there's something wrong and we have to take some sort of action. So FSD is doing that constantly. It's predicting what the road's going to look like. And if something happens, like a car comes in there or a pedestrian, then it says, oh, wait a minute, this is out of where it's supposed to be, my confidence level. Let's go ahead and do something else. So that's the anticipation you have. We're always doing that. So when I tell you to grab the bottle, or if I tell myself to grab the bottle, I already imagine in my head what it's like. I already played that through, and I go ahead and do it. And if something happens along the way, like suddenly my hand bumps something, like, oh, wait a minute, I wasn't expecting that. What was that? And then I realize, oh, I have to do something a little bit different. So you get that image in your head and you exercise it. Now, there's 2 ways that we can do this. One, I can say, Jan, grab the bottle. And you will imagine it and you'll go ahead and do it. So you'll take my words and you'll translate it into your internal representation of what's like to move your arm. You just get that feeling, you get that sense, but it's almost like an internalized language. The other way of doing it is I can look at you in the eye and I can point at you and I can like go down there and you'll kind of get the idea that, oh, this is, or maybe I'll look at it and I'll show you my hand and I'll grab a bottle and there'll be one right in front of you. And the idea is I want you to mimic what I just did. Now there's no language in there. It's more or less just you're looking at that and you're seeing that, and you could internalize yourself. It's like, oh, Scott wants me to grab the bottle. You can, have that internal dialogue in there.
Yeah.
Or you don't necessarily have to. You can look at that and sort of visualize the process I just did and then do it yourself.
Mimic.
So I can imagine that's what the bot would be doing, is it's seeing that, and it needs to internalize it into whatever its representation is going to be for that.
Okay,
and
makes
once
sense,
you have enough of these gestures, these different tokens, at some point, just like, composing anything, you just put the words together to make whatever sentences and paragraphs you want, so long as they make sense and they're grammatical. And so there's going to be some internal grammar of how all these different movements connect together that make sense. And then at some point, the robot can ad lib. It will see a completely new situation and then sort of figure out, this is how I do this particular task. And
one key factor with that together is when you have your experiences in your car, you can't really share them with me over the air. And that's something that's hugely important with that, because the more bots you have for training, the more bots you have running around, the faster they're going to learn, because they're going to share the information, they're going to share the data, they have the same database. And I love this analogy where with this dream state, or now the simulations come into that play as well, with Tesla Bot actually dreaming, more or less, going to a station, charging up, and still learning new movements from. It's not exact,
it's weird,
but what's interesting to think about it like dreaming. I mean, they could dream while they're doing something. I mean, that doesn't need to be on the charging stations, but for the update maybe, and everything. It's so crazy. And it's such an exponential growth. You could really see them if you solve manufacturing with those things, and go into the state that the Tesla Bot can do something useful. If we are at that stage, I think that's why I think your prediction with what's your prediction, 2025 or what was it?
Okay, for you, we're doing something useful or kind of affecting the bottom line.
Yeah, a little bit further, maybe. Yeah.
2025 for sure, but I would think, Elon has said useful work, and once it's started to do useful work, it's already affecting the bottom line. Yeah. And maybe we don't see it, until some quarter in 2025, and probably what they're looking at is that they're going to want to deploy it within, Fremont at first in some areas, not widely, but probably in there. Maybe they're thinking of bringing it down to Austin, but the reality is, I think it's all about Giga Mexico. So that is when they have to have it ready when Giga Mexico is ready to go up. So I think that's what they're aiming towards. So if Giga Mexico is slowed down a little bit, then maybe they slow it down a little bit for that. But I think that's really what they're ramping up for, is more or less that, not so much to replace the entire workforce in Fremont. Fremont is more or less there as a place for them to experiment, to prove that it's going to be working. And then, probably through attrition, they will slowly start to take over certain jobs. And then there's always going to be those very high skilled jobs that I think are going to be very hard to replace in Fremont without them completely changing the line to the unbox method. Because that's part of the idea of the unbox method. And remember, Lars is the person who presented that, and is a big proponent of it, is that it's really designed so Optimus can do a lot of that. Because one of the things that Optimus will not be able to do is put the harnessing inside the car. So, and part of the final assembly is like all the wires that have to be run through there. So when they put in, the dashboard and everything else, you have a lot of harnessing and lines that have to be put together. And it's very difficult to do that, but because you have to crawl in the car to be able to get in there. Yeah. Now, Optimus is going to be able to work with wires. We've already seen that, able to do it, and probably plug them in. We'll have enough dexterity for it. The question is whether it will be able to access a tight space, like a human can. And it's going to be difficult because Optimus doesn't have the flexibility in its head and in its torso. So it was, asked me by somebody the other day, it's like, oh, do you think Optimus will be able to be like a valet bot? So Optimus will drive anyone's car, even if it doesn't have FSD, like a valet park attendant. They're like, no, because there are very few cars that Optimus will actually be able to get into. So think about it. If you have like your neck is really sore, you can't bend your neck and you've got a sore back, it's really hard to get in your car, isn't it?
Yeah.
In order to get in your car, you have to be able to do this.
Yeah,
Optimus can't do that.
Have a flexible spine. Actually, the spine is very important.
It helps. You either have to have like a van with a very big door that's opened up right that you can kind of like go into. But most cars are down very, very low. And if you're tall or anything like that, it's very, very hard. Optimus is, I think, 5'8", so that's not exactly short and definitely does not have flexibility. So I don't see Optimus getting into a car and driving it because of that. And if it can't do that, there's no way it's an assembly line going to be going in and reaching underneath and plugging a couple of cables together. That's going to be very difficult, except in Giga Leon, where you're going to have the unboxing method where everything is out in the open and very easy to do.
Yeah, like so, here, like really their concept, and this is so interesting. Now everything ties together because I think what we are doing here within the Tesla community is just scraping up like breadcrumbs actually, and try to put them together again, and try to figure out what the thesis or the thought process of Elon Musk actually is, and we see something like this is like a picture that's okay, yeah, it's for the bot, but we can't really grasp what this means. This is the concept that they try to implement at Giga Mexico actually, and this already uses bots. So I mean, we see it here, but we can't believe it, and we think, oh, okay, I don't know, it doesn't seem so relevant, but it is more relevant that we actually think or can grasp. I just wanted to add that.
Yes, so you're going to have things a bit more open. It doesn't mean it won't be able to do certain tasks in Fremont. I'm sure it can do a lot, but it probably won't be able to do all of them. But in Mexico, it'll probably be designed that it can do almost all of them, all the operations.
Yeah, absolutely. Yeah, this is absolutely crazy. So the unbox method together with the Tesla bot is the way to go. So the Tesla bot is especially important for the next gen vehicle and for the production is your thesis, and we see those indications everywhere already, and people already talked about it. So it's not as secretive as we think, but that's something you could easily miss when watching everything. I mean, we've seen the bots here in the explanation, but people, I can't even believe it, but we will see it. It's crazy. It's absolutely crazy. But Scott, maybe for the end of the episode, we can maybe go into the territory of the future. What do you see there? And maybe we can start with the last part of Elon's answer here with Neuralink, the combination with Neuralink. That's pretty interesting. And then we can go to the future of where everything is headed. And I think that's very interesting for the audience.
So this is a part I think we entitle Resistance is Futile. See, I should say another cool thing about Optimus is that there's just in the US alone, there are 2 million amputees. And I was just talking to the Neuralink team. And by combining a Neuralink implant and a robotic arm or leg for someone that has had their arm or legs amputated, we believe can give basically a cyber body that is incredibly capable. So, again, that sounds very much science fiction. And to kind of pull it into the science fiction, he makes a 70s reference here. $6 million man in real life, for those who may know that there was a television series back in the 70s with Lee Majors called The $6 Million Man, who was this idea of a cyborg. And of course, there's no way you could have built something like that for $6 million even back then. But now because of all the development, and everything, and he says, but it won't cost $6 million. $60,000 man, and which is possible. Now I don't know if he just pulled that number out because he knows it's not going to be $6 million. It's going to be as a reference, or whether that's a number they've had in their head for the cost of Optimus, or
I guess
the value of Optimus, or something like that.
Yeah,
so
I guess
it's just a
reference.
But once you're able to scale up, there's no reason why you couldn't do that. And that is absolutely incredible. Now, to do that, I'm pretty sure the actuators might change a little bit, to be maybe a little bit smaller. in some cases, because it's still a little bit big and bulky. But he did mention that the actuator is going to be lighter and tighter. Sort of talking about that. So I wouldn't be surprised if the November-ish one we come out and we say, wow, that shoulder looks a lot smaller. Everything looks a little bit smaller and kind of packed in there. So they may have been able to figure out how to get kind of the volumetric energy density out a little bit better. The other things that's always going to be important is that, the power source is going to come along with it. So for any sort of prosthetic limb, you have to figure out how you're going to actually get the energy in there for it. What kind of battery pack you're going to have that's going to be useful. Is it going to require a backpack or something like that? So you're going to want to do something that makes it work. And that's another thing that to kind of point out that a lot of these actuators don't really have like a built-in brake, or that they're usually they can be back driven. I think on the fingers, you can't back drive them, but all the other actuators, if you put your arm out, we know that if we are moving the arm, it takes energy. We got to run that motor. But what you don't know is actually hold the motor out there. You also need a little bit of energy to keep it locked in place. So just standing, if you want Optimus to just stand the whole time, you get over there, you just can't say, okay, stand at attention and just like lock everything down. That's not going to be the case. You're still going to be requiring a little bit of current to do it. Now, in some cases, you might be lucky. Like if the arm is straight down, the elbow straight down, then maybe you require like no torque to do that. But as soon as you lift that elbow up, suddenly a little bit of torque on that joint, you're going to be consuming a little bit of electricity. So again, you want to make sure.
I just wanted to make a reference here, just like the gimbals, for example, those gimbal camera gimbals, where they hang like this and then they straighten up, and this is the default position, and it's every motor is running, of course, to
even
hold
though it's not running, even though it's not running, it's running. So
it's running with current.
And so you say, oh, it's not consuming any energy. It's like,
no, of course,
consuming energy. And so you have to design everything thinking about what the idle state is going to look like. And so you want to make sure that these things are not consuming a whole lot of energy. It's the future potential will be great. And that is an absolutely wonderful application to be able to do that. And I'm not surprised they have thought about that, because everyone has already thought about that. Everyone's like, oh, someday, we could probably make prosthetic limbs out. And now Elon has actually come out and kind of said it, and that the Neuralink team is thinking about that as a possibility. And I don't know when we will see that. It's again, very much science fiction, but it's just kind of weird that all these things that I saw as a kid, might actually be coming true.
Yeah.
That, there's serious discussion and these things are happening. So it's like, wow. Science fiction sometimes becomes science fact before you know it.
And I also think science fiction also inspires our contemporary times always a bit, and people are inspired by this and try to figure out how to do it actually, because how can we really make it work? And then the creativity starts. But how do you think that? I think that's a great transition to the topic of how the different mass companies can be utilized together to develop something new. For example, the Neuralink team together with the Tesla Bot team developing a prosthetic arm or leg, and those kinds of things. And how do you see, for example, the acquisition of Twitter, or now X? Or Tesla, like you said, the Tesla language model that might be out there. How do you see those companies getting more and more combined? Do you see something there? Do you have a thesis a little bit in that camp?
My only thesis is that there is a grand scheme and how they all connect together, and we can already see the synergies. Elon's mentioned that a little bit, that when it comes to recruiting, it's a lot easier to recruit people that have the option to work for both companies. So a lot of engineers that work at SpaceX also will work on projects in Tesla, and vice versa. They're allowed to. And he mentioned that the individual they hired for the materials group to head that up was over at Apple, and he really didn't want to, just work for Tesla, just work for SpaceX. He wanted to be able to kind of work on both. That's what sounded interesting to him, and that makes sense. And so when you hear, there's some of these crazy things. I think it's Elizabeth Warren that somehow doesn't like the fact that
I've heard that
Tesla
stupid.
is somehow working with these other companies, and she doesn't understand the synergies that are there. That the giga casting was possible because the materials group over at SpaceX that was working with this stuff was able to come over and solve the kind of aluminum they needed for the gigapress to work. And then they go back and they come up with another form of stainless steel, which Tesla is then using. So there's huge synergies going on between them. And that's just between SpaceX and Tesla. And let's just imagine what goes on, with the Boring Company and some things that are going on there. What is, again, the reason for the XAI is because a lot of the researchers didn't just want to work on FSD; they wanted to work on something else. And in a sense, Andrej Karpathy left because he wanted to be more involved in kind of the large language model things. Like, okay, I'm not going to make that mistake, so I'm going to set up something like that. But they'll have access to Twitter because that's where you're going to be able to get the input data to be able to train the models.
Exactly.
So there's this constant synergy that's going on, and then you can imagine it's like, well, they're kind of getting into lithium and building the batteries, and like the Boring Company, okay, they're making tunnels right now, but could also be useful for mining. And then at some point you get the mines and you get the miners in there, but do you really want to send people down there? Why don't we send bots down in there? And Tesla's got so I mean, is that the case? I don't know, but I'm not the first one to sort of connect those dots, so to speak. And then of course it makes sense for SpaceX and everything else that once you start, either going to the moon or going to Mars, it might make sense that the first astronauts are actually astrobots, that they're able to set everything up for when we finally get there. And then, if you want to take it a step further, imagine, asteroid mining or something like that, if that's going to happen, which, I mean, it's literal gold mines out there just waiting to be exploited. But it's way more difficult than people think. So it's I just want to say, it's like, oh yeah, we just send a rocket there. So it turns out there's a lot of technical challenges there, but all those potentials are there. And you might say, he's just using Tesla resources to build the bot that he wants for Mars. But if that bot is already making the margins, increase,
what's
then
the
cares? Who cares? And as a shareholder, I'm happy. And if you don't like it, then sell your shares,
Get out of here.
Not financial advice.
I Scott, absolutely true. I think that's so interesting, those synergies happening. And to Elizabeth Warren, I just can say that's she views that through such a strange lens of, I don't know. I mean, are the workers forced to work at those companies? I don't think so. No, they can do it. It's just a project. I mean, come on. It's like,
and the thing is, they do take care of the accounting between them. So someone is able to move between it. So they set up the HR to make sure to do it. The other thing is, you just don't imagine how important cross-pollination is that you want to get people out of their silos, that they get exposed to something else. And then they come back and they go, holy cow.
Inspired and everything.
Man, and think about it, is like, if you were a computer scientist and all you studied was computers or something like that, and you didn't know a lick about music, playing musical instruments or something like that, you wouldn't be able to come up with a music app. But I've known a lot of guys who are really good in computer science, and their hobby is like, playing the guitar or the piano and music and stuff like that. And then one day they go, hey, guess what? These things combine together. So you have a lot of people, they take their hobby or take something else that they have, their life experience, and they're able to then apply it to something else. And then you have these Renaissance people that have like 3 or 4 of these different things and pull it together. And that is where things happen, is everything happens at the interfaces. If you look at biology, where do the interesting things happen? They happen like along the coastlines, where the water meets the land, or where the air meets the water. It's like, that's where everything kind of happens there. It's because everything comes together around there. And once you start getting just deep in the water, not so much so interesting. Deep down or high up, it's like everything is at the interfaces. And so the more of those things you kind of bring together between the companies, the more exciting products are going to come out. So there's a convergence of technologies. Every company is looking at the idea of someone going on a sabbatical. They set that up. I want you to go on a sabbatical. And maybe that means you just hike the Himalayas for a year and then come back, or you lecture at a university, or you go to another company and come back and tinker, because the whole idea is we want you to get a different life experience and then bring that in to the company. So I see absolutely nothing wrong with that. And it shows like a complete lack of understanding. See, that's the difference between a politician who has never actually worked in the real world who's never run a company, who's never started up a company, and is just taking theoretical classes in economics. It just doesn't work that way. So it's never listen to politicians.
Yeah, okay, great advice there. But I think especially for those high performers that are employed by Tesla, how do you keep them? That's so difficult because they are so deep in such a deep level, and if something sparks their interest, they can't get it off their shoulders. This chip, they have to follow and pursue that, or maybe they just want to be flexible enough to pursue their interest because this inspires them and this helps them get new ideas. For example, I think Andrew Carpathy is the best example for that. He saw that something is happening with the language models again, and he was like having a little bit homesickness or something, you could say. And then he just went there and but the best thing would be, hey, you're always open. You can work on this project. Go do it. Come back whenever you like. I mean, the door is always open for him, I think, of course, because he was such a top level such a top level and such a great performer there. But actually, those geniuses, you cannot. What you want to do? How do you keep them?
And you don't want to constrain them. That's the thing. You really don't want to. You don't want them. You want to give them that ability to go out and try new things. Potentially fail or do something that's kind of silly, or maybe they come in one day and they just have some crazy idea, and you just kind of look at it and go, "Yeah, let's just play with that. Let's just see what we can do with it. Maybe something comes out of it." And it happens all the time. There are examples of companies, of guys that were tinkering, doing something completely different that had absolutely nothing to do with the corporate mission, and they ended up discovering something that ended up becoming the thing that was, the biggest product. I think like Post-it notes was like one of those examples or something like that. All these other things, you just keep on going on down the list. I think in Bell Labs, there was like tons of examples of like that, of guys tinkering stuff. There was an example in this one company where a guy was like playing, I think it was like Sanders Instruments, that he was using their stuff to create a video game. This is like back in the 70s or something like that. And so he was kind of screwing off, didn't want to do it, but eventually his manager saw that. But rather than scolding him, he realized there's a possibility, and they actually patented the idea of a video game from that, and then started producing these displays and everything else. Now, eventually, other people had better hardware and stuff like that, but they had the patent on the video game idea. So
it's absolutely crazy.
So let them tinker, let them come up with other things. You never know; it might actually help the bottom line.
And this is a prime example how to utilize those potentials in the company and accelerate the rate of innovation even further, because that's I would say the main mission of Elon maybe, but Tesla has a different mission: accelerate the world to sustainable energy and transportation, and accelerating the rate of innovation is very important to become a spacefaring civilization. And this is something that he's most passionate about. So absolutely interesting times we live in, right? It's great. I mean, we too discuss the future here in a small channel, and the Tesla community is full of those kind of nerds talking about everything. And it's a great community. I really enjoy it and love it also to talk to you always. Absolutely crazy. Do you have for the audience, maybe for the end of the episode, some things you were working on, or I know most of them you can talk about, but something you find very interesting right now, or things that you look forward to, or something you want to plug?
What I'm looking forward to is more of the convergence of AI with virtual reality and augmented reality, and how that's going to sort of shift the paradigms on how we build virtual models of the world for engineering. And because right now I think it's too tedious. My general thesis is that you take any engineer, a CAD designer in the cases when we're doing a simulation, and if you describe to me the simulation work you want us to do, within a couple of minutes, I already know in my head what it is we have to do. The problem is it will probably take me maybe 2 weeks and everything, clicking all the buttons that I need to click and this and that. Maybe, having to write a little Python script, or realizing that, oh, there's this one thing in here which is going to be a little bit tricky that we're going to have to work around and all that. But there's a lot of things in there that I just see as almost like cut and paste, but I still have to go through and do everything. Our engineers would have to do it. CAD designer would tell you the exact same thing. So why not figure out how to get your AI to do that instead? So you describe the actual problem, and it goes and starts producing these candidate layouts or drawings or something like that gets like 95% of the work done. And then you can go in and you can start iterating on that and making changes, suggestions, and doing everything else to speed that up. And then I think you want to couple that also with more of a VR world. Now, one of the problems with the VR world is, do you want to live in a VR world 8 hours a day? Now, I know there are gamers that can do that. A lot of people say that would just be exhausting if I had to do all my CAD work immersed, unless it would have to be super comfortable. But right now, most people don't, which is why they prefer to do it on a flat screen. I hate the flat screen. I think the flat screen is an impediment between me getting the information into that world and getting the information back out. If I'm immersed in there, the data flow is like an order of 1 or 2 magnitudes faster as far as my being able to visualize what's going on. And if I come up with a way of being able to interact with it better, at least viewing it is a lot easier for me to be able to do. So if you can accelerate those things, then you're going to have a paradigm shift on how people are be able to come up with new models, because it doesn't take them so long. You can now start to iterate it, and that will become, but a lot of it has to be describe it. You can kind of go in, do a little bit, jump back out, maybe take care of a few other things. And then when you're kind of rested, go back in. But the idea of designing 8 hours a day, it's going to be tough on a lot of people, because it's like 30% of people cannot really go into VR without getting motion sickness right away. I mean, instantly like that. We had a managing director who said that within 15 seconds, he would get so dizzy and he couldn't drive home afterwards. It would take him hours to get his balance back. And so there are a lot of people, and that is really disorienting. And I was surprised what the number is.
That's crazy. Yeah.
And I found that number to be the case, because a lot of times we were showing it pre-COVID, we would have these VR headsets and stuff like that. And there'd usually be like a group of 3 people or something like that. And there's always like one person that didn't want to do it. And we thought, he's probably a germaphobe or something like that. And the reality is he's put it on one time and he got so queasy, he just doesn't want to go through that experience again. So at that point, I learned that you never pressure someone to put it on. If they say no, there's a reason.
Yeah. Okay. Yeah, but very interesting. And maybe we have the Tesla bot as a mediator for those spaces of the 3D world, because we've already seen sadly I don't have the video here, but last time we or in our first interview we did with John. I'm going to link the video also here, where the person shows Tesla bot how to do things, and those hybrids with the inputs of the robot and the human preparing or trying to tinker with that. I think this could have a halo effect on the precision, maybe on the virtual space.
It's going to improve it, and the fidelity will be good, and then the update rates will be such that you won't have that virtual sickness anymore. Because a lot of it was a problem of that you moved your head one way and the screen didn't move with it. And that got very disoriented, because then you wanted to see something, you move your head back, and then it would do this back and forth, and you would get sick really quickly. But as the resolution gets better and as the response rate gets a lot better, it won't be bad. And probably the new Apple Pro, that headset, they're doing like a lot of things probably to anticipate what you're going to do, to almost get ahead of the games. That's going to prevent a lot of that lagging, so you don't get sick. So we're going to see improvements in there. In many cases, I mean, I don't know if this is a good analogy of what's going on, is if you ever saw the movie Avatar, which you probably did, but maybe some people haven't. I mean, the whole idea was that someone was in a virtual world, experiencing a world somewhere else, and actually having what was in effect a robotic body or another body going and experiencing everything out there. And that's what we were talking about. You'd be able to do with Tesla Bot, to either teach it or help it when it gets stuck in a task or something like that. People see what's going on. No different than what Waymo has to do if the car gets stuck somewhere, that someone goes in and takes over and starts to drive it out of that position and then let it go again.
That's absolutely, that's true. I could really see a workplace where the fleet manager of the Tesla bot sits there and, oh, here's a problem. Then he goes in his VR suit, stands around, maybe even with walking pads, like you see, and then just does the task manually and calibrates the robot or something like that. That's like a mouse. It's like a mouse
there's already
input.
a company that does that. That is their what they do, and it's a company called Plus One Robotics, where they're in like a packaging industry where you have these robots that are sorting packages that come in a conveyor line and pulling them out and deciding, oh, it's supposed to go over here or there. And because the packages are different sizes and assortments, they have a camera system which is going in and sort of finding its target, and going after it and picking it up. And then sometimes the camera system may just get lost and not sure what to do, and it's stuck. And then it sends a request to an operator, which is actually, could be hundreds of thousands of miles away in this control room. It's like, oh, this one over here has failed, because they kind of do it as a service for a lot of their vendors. And then they'll just look down there, like, oh, that one there. So it comes in and the operator intervenes for a second or two to tell the bot to do it, and then the bot goes on its way. And the bot is able to usually do these picks very successfully, 99.9% of the time. But remember the March of Nines. And so what that means is like, 1 in 1,000, 1 in 10,000, whatever. And if you get a lot of those bots out there, that means several times a day, one of these bots is stuck and it just needs a little help. And one guy can do that. And he can control a lot of these bots from many, many different areas. So it's already been proven that you can do that. And it's just that Optimus will be a little bit different because it'll be maybe more immersive to be able to figure out the problem, as opposed to just pointing at a package. Is going to be a more complex situation.
Yeah, or those surgery robots with 5G technology that can really, like, the movements of the operator really is like the connections. There's also a technology there that it's gonna get better and better. I think. If those synergies play out all those years, the next 30 years, I think we're gonna see like really advanced robots that we can't even
there's
imagine.
Already a company that does something like that called Monogram Robotics that's demonstrated that they can do it telerobotically from a distance. That they've done operations in Austin with a surgeon in New York, and the robot that's doing it already has a pre-programmed task on what it's going to do, because basically they're using the robot as like a milling machine. Okay. So when you're doing an operation, you have to do certain things to prepare the bone, and you're going through there. And I mean, that's basically what every surgeon will tell you. The operating room is, it looks like a carpenter's wood shop. You get the same stuff. You're just going in there and you're trying to get something. The problem is they're doing everything by eyeball. And that once you get good CAD data, if you get a CAT scan of the bone, you know exactly what the bone looks like. And if you're able to put these reference probes on there, that you're able to track the bone in real time where it is, if you know exactly where it is, you can precisely machine it, even if the leg is moving around a little bit. So they get it set up for that. So now you get this bot that's going over and machining it. Now the surgeon can kind of watch what's going on. They know what it's going to do. It's a pre-grown task, just like in a CAD system, but you've got basically a gas pedal that you're able to push, and whether you want to go faster or slower. And so if you see something you don't like, you're then just able to quickly stop it and retract it back out. So that means you have a surgeon in that loop that could either be right there in the operating room watching what's going on, or it could be 1,000 miles away doing the same thing. And that's so but the thing is, he's sort of controlling the robot, but the task has already been worked out. So all the math and everything is there, because they know exactly now the cut has to be done exactly like this. This is the location, this is the angle, and there's some connecting tissue around there. Be very careful when we go around and we start removing that bone, that we don't go into some other vital tissue. And so that's why you have a person in there, and probably for a variety of reasons, like malpractice, and insurance and everything else, and the legal reasons. Eventually, the bot could probably do it without the surgeons, but we're not there yet. Just like we're not there yet with robotaxi. And the thing to mention is the bot is not doing the whole operation. The bot is not opening up the patient. That's being done by surgeons. It's just that finally you get to one stage of the surgery, which is very, has to be very precise and can really only be done by a machine. I mean, ideally, they'd like to take the bone out of the body and bring it over to a CNC machine, do what you want, and pop it back in. But that's completely impractical. You have to do it in place.
Absolutely. But this is crazy. So we live in interesting times. Great to witness everything, and we can just take out the popcorn and look at what's happening. And of course, you moving around in that field and working in this field, you have to go there and implement some stuff that technology brings, but it's absolutely great to see those developments. So thank you very much, Scott, for being on. And I think when my audience still has any questions to now I speak to the audience here for one second, please write it down to the comments. I really like the discussion there and discuss everything. So everybody, please follow Scott on his socials. I'm going to link them down below in the description, of course. And here's again his Twitter handle or X handle. I have to call it now.
Yeah, whatever.
I don't know.
Oh, that's right. It's an X handle now.
The X handle.
It's still current.
Yeah, it's still Twitter. It's still Twitter.
Current, but it is my X. It's my X handle, but it's current. Yeah.
Yeah. It's a little bit difficult now to navigate this.
Yeah. So, are you my Twitter friend or are you my X friend? You know, that's just
it kind of sounds bitter. I'm your ex. Right. Okay, it doesn't sound right.
No.
Okay, so everybody, please follow Scott, and if you have questions to him, you can just tweet at him or tag him or mention him in your tweets. Please do that. He's an awesome guy, of course. Thank you very much, Scott, for being on. And I think there's only one last thing to say now, and that's goodbye, everybody.
Auf Wiedersehen.
Wasn't this episode awesome? Let's accelerate the pace of innovation by subscribing to Tesla Fix. This is my absolute favorite channel on the whole interwebs.